Okay, we're ready to roll here. Good afternoon, everybody. I'm just going to go over some of these sections. I'll go over most of the sections anyway for this class, Intermediate Algebra. And I'm going to start with section 2.3 and just touch on function notation. Okay, and what it means. So thus far in beginning algebra, we did equations that were, for example, the y equals mx plus b equation when we were graphing, and we use y, and what else can I say about this? So similarly, this could be y equals 3x plus 2 as maybe a familiar equation that you've run across when we were doing graphing. All right, so now as we get into function notation, we've got a slight change to this, which we use interchangeably throughout, starting from intermediate algebra on. So for example, this, I could say y now is going to be on the graph. We know that this axis here is x and this is y. Now the function notation comes there where we replace y with this notation of f of x. Okay, because when I replace x with a number, it results in y using, this equation. And now this function notation allows us to specifically say what value for x we're going to use in this equation. So if I have f of x equals 3x plus 2, then that's correct. We're saying that x I'm going to replace with x, and what would be the expressions, what would be the expression would be 3x plus 2. Okay, but now we could also use this function notation to say f of 1. And now what they're telling us to do is replace the 1 for the x in the expression, 3x plus 2. So I'm going to replace that with 1, so it's going to be 3 times 1 plus 2, which results in 3 plus 2, and so f of 1 equals 5. All right, so after we implement the 1 in the expression, then I could revert back to y, and y equals 3 plus 2, therefore y equals 5. So it's kind of like a 2 for 1. Oh, I think we cut us off on the bottom of this. I'm just writing this out so you can see it's y equals 5. All right, so that's the general idea of function notation. All right, so let's do some examples here. All right, so here's our example, and this is on page 177 of our textbook. The equation is f of x equals 7.5x, and they want us to find f of 0. Okay, so f of 0 is, I'm going to plug in 0 for the x in this equation here. That's what the problem is. So that's easy. So that means f of x equals 7.5x, and we're finding f of 0. I'm replacing, I could write it this way, f of 0 equals, well, I'm going to replace the x with 0, 7.5 times 0. Really writing it out here, so I hate to bore you like this, but so I make myself clear. So then I've got that y, I'm reverting back to y now, equals 0. Okay, and that's my value for f of 0. And that's all there is to it. Okay, for my next operation, f of 10, I'm evaluating f of 10, just rewrote it over here. And I'm going to replace the x with 10 this time. So it's going to be f of 10 equals 7.5 times 10. So therefore, y equals 75. And again, we're done. And then we've got one more to do, and that would be f of 20. So I'm going to take the same thing, and instead of having f of 10 here, I'll see if I can make that change. Let me change colors here a little bit. Make that f of 20. Okay, so what does that mean? I'm going to replace 20 for the x in the equation. So f of 20 equals 7.5 times 20. And it looks like y now is going to be equal to 20 times 7.5 is going to give me 150. And there is our introduction into function notation. We'll be using this in this section here. Okay? All right, let's move on. All right, here in example 2, where we're using function notation, I'm looking at this function s. S of t equals 60 divided by t, and they want us to find these two guys here. First, find s of 10. So it's like s of 10 equals 60 divided by 10. I'm replacing the t with the 10. Therefore, y equals 6. Okay, the other one is s of 8. All right, so the next one is s of 8. Then I'm going to put the 8 inside that function notation. So I'm going to replace the t with the 8. And that's it. So it would be y equals, and what is that, 30 over 4, which is also can be simplified to be 15 over 2. And that would be the result of using my function notation. Fairly easy once you get it. All right, here's another one in example 3. A little bit different, where it is, well, it's got a little story that goes with it, where a painting is purchased as an investment for $125. If its value increases continuously so that it doubles every 5 years, then its value is given by this function. And this function is v. I don't like red, but I'll use it one more time, v of t. And the function then is going to be 125 times 2 raised to the t over 5. Now that's an exponent there. So I'm going to replace t with what number here? So let's see, they're saying to find v of 5. Find v of 5. v of 5. Okay, so this becomes v of 5. And I'm going to replace the 5 for the t in this expression. So it's going to be 125 times 2 to the 5 over 5. All right, so this ends up evaluating to be y equals 125 times 2. 5 over 5 equals 1. That's 2 to the first power, which is 2. So therefore, y is going to equal 125 times 2, which is 250. Okay, a little kind of nice stuff there that they're introducing us to, using the t with the exponent. Okay, let's see, what was the second one? I think you get this, I hope so anyway. V of 10 is the next one. So what do I have to do here? I'll get my eraser out, and I'm going to substitute, instead of 5, I'm going to put a 10 there. Let's see if I can erase this. Okay, I'll even erase this here, and I'll substitute what I had, and I'll use a different color now. So I'm going to put, this is going to be, whoops, not v of 5, but this is going to be v of 10 now. And the 10 will go here where the t was, and now I can evaluate this. So it's going to be 125 times 2 to the 10 divided by 5 is 2. Okay, so that means that's going to be 2 to the second power. So therefore, y is going to equal 125 times 4. And 4 times 125 gives you 500. And just as the problem was describing, it's going to double for every 5 years. Okay, so there's our example of another function notation. Let's see what else they have for us here. All right, let's check this out on example 4. It is saying a balloon has the shape of a sphere with a radius of 3 inches. That's an inflated balloon, and an inflated round balloon, like the shape of a basketball. It has the shape of a sphere with a radius of 3 inches. Use the formulas to find the volume and surface area. All right, so the formula, less popular formula for the volume, so I'll say V equals, what is that, 4 over 3 pi times the radius, and that radius is going to be cubed. Okay, we'll start off with that. And the surface area, so the surface area is equal to the 4 times pi r, and we're going to square that. Okay, so here's our two formulas they're talking about, and they want us to find v of 3, and 3 is the radius. Okay, so that's all I'm going to do is plug in 3 for the r. So I'm going to have 4 over 3 pi 3 to the third, and I'll evaluate all this. Use your calculator, whatever the case may be. And what have I got? So 3 to the third is 27. So I've got, this will be 4 over 3 pi times 27. And then looking at all this, I can do the 27 over 3 here and say 3 goes into 3 once, 3 goes into 27 9 times. And I'll answer this in terms of pi. 9 times 4 times pi is 36 pi. All right, so that's the volume of the sphere with a radius of 3. And I'm going to plug in for the same plug-in method for the surface area. I'm just going to use 3 and plug it in for r. So that'll get me what? Let's get rid of this real quick. And I can use this side of the board to say 4 times pi times 3 squared. 3 squared is 9. 9 times 4 is 36 pi. Well, isn't that odd? We got the same answer for both of them. Surface area and the volume. Okay, next. Okay, here we go. Here's our function now. Got a little bigger. So they want us to evaluate f of 0. Substituting the 0 for the x's in this equation, I end up with, let's see, I'll write it up as 3 to the 0 squared plus 2 times 0 minus 1. So f to the 0, not f to the 0, f of 0 equals negative 1. This is 0, so it's gone. This is gone. I'm left with negative 1. F of 3 here, I'm going to substitute 3 into this equation. So let's see. This will give me 3 times 3 to the second power plus 2 times 3 minus 1. And what will this give me? So here I've got 3 to the second power is 9. 9 times 3 is 27. 27. And then plus 6 minus 1. 27 plus 6 is 33, minus 1 is 32. And the last one, f of negative 2. So, oh, we've got negative. So that's why I always put these in parentheses, by the way. Really helpful. And it's not that inconvenient to do. So let's see, I've got, let's try that. So it's going to be 3 to the negative 2 in parentheses, raised to the second power, plus 2 to the negative 2, minus 1. So now let us evaluate this. I've got negative 2 to the second power is 4. 4 times 3 is 12. 2 times negative 2 is negative 4, minus 1. So this is 12 minus 5 equals 7. There you go. Okay, here is a major problem in terms of work and effort. What's happening with these? So I'll squeeze them in here or get them in here somehow, because we've got to do, we have two functions on this example, f and g. And although I label these functions f, I'm also going to label it g, but I'll do it one at a time. So this is f of x. So here's my function f, which all these apply to. Okay, so that means I'm going to put in, I'll do these one at a time. Let's see if we can do this in our head, except for maybe down below here. So f of 5. So I'm going to substitute 5 in here. So f of 5 is going to give me 4 times 5 minus 1. And that'll be 20 minus 1. That's 19. Okay. The next one, f of negative 2. So I'm going to substitute negative 2 in for the x. And if I do that, it's going to be 4 times negative 2 minus 1. And that's negative 8 minus 1 is negative 9. Okay, here's my favorite one, 0, f of 0. And plugging in 0 for that, it's, well, I do it here. 4 times 0 minus 1, and that's going to give me negative 1. And now we come to some funny stuff, f of z. Well, if the idea of function notation is to plug in the value of the stuff that's inside the parentheses, I'm going to call it stuff, because this is a letter now. So I'm going to plug that in as if I were a number. So this will end up equaling 4 times z minus 1. I can't do anything with it, but that's my answer. This is f of a. Same thing. This will end up being 4 times a minus 1. And then I've got this nice thing here of a plus 3. So that'll make us think a little bit more. I'm going to rewrite this one as 4 times a plus 3 in place of the x. And what else was there? Minus 1. And now I can go about my business and simplify this. So this will give me 4a plus 12 minus 1. For a final result of 4a plus 12 minus 1 is 11. Okay, then we do the same thing for the g of x. And I don't think it's going to give you much trouble. I'll have you go and do these if you like. We did them in class, etc., etc. I think you get the idea, though, with this. Okay, a couple more examples here and we'll be done. Okay, in example 7, this is our function written a little differently. It's given by f equals these ordered pairs. All right, they want us to evaluate f of negative 2. So I'm going to look for the value of negative 2 for, remember what this represents in function notation. The negative 2 represents the x value. Okay, so therefore I'm looking for the corresponding y, because remember, this notation of f of negative 2 changes to be y equals. Y is the same as f of negative 2. So if I look at my ordered pair, I see this negative 2, 0 is the one I want, because negative 2 is x, and 0 is what my resulting y is. And remember, for this to be a function, all the x values have to be different. They can't be the same. They can't be the same value. Okay, and that's a good reason why right there. So f of 3 then, I'm looking for 3 in the x coordinate, and there's 3. So my value here, it's going to be, for y is going to be negative 1. And f of positive 2, that's here. So my result is going to be y equals 4. Okay. And to throw my own little twist on this 7, 5. Well, what if this were written as f of x equals 5? See, it's not in the place of the x, it's what the result is. So now this is saying, remember, f of x is the same as y. So it's saying when y is 5, what is x? Just reversing it. So I'll look over here. My y value is 5 in that last ordered pair here. So therefore, the x value must be 7. So x equals 7. And we're getting that right from that ordered pair. Okay. Check example 8 out. They save the best for the last. And this will maybe rattle you a little bit when we're talking about compositions. All right, and notice here what we've got. Kind of like a 2-for-1, where inside the parentheses, order of operations, I'll say it, I've got two functions now, one f and one g, with two different expressions that go along with them appropriately. All right, so let's see. I'm going to have to figure out what is g of 2 first. Well, here's my function g, and I'm going to put the value of 2 in for the x. All right, so that means g of 2 is going to equal 3 times 2 minus 1. So g of 2 equals 6 minus 1 is 5. Okay, so given this idea of substitution, that's really an important skill of substituting. If g of 2 equals 5, I'm going to substitute that for the g of 2 in the parentheses of f of g of 2, but f of g of 2 is 5. So I've got that done. Now I'm going to evaluate f of 5 and the function 5, so I got to go back to this function to evaluate it. All right, so that's going to equal 2 times 5 to the second power. And therefore, y equals 2 times 25, which equals 50. And that was the first one. All right, let's see. I can get the second one. Give me a second. Okay, so here's the part B of this example 8. So kind of like just reversed it. So here I've got g of f of 2. So I got to figure out what f of 2 is. So here's my function f here. And I'm going to substitute 2 in for this. So it's going to equal 2 times 2 to the second power, which looks like it's going to be 8. And what's 8? 8 is f of 2. Okay. And therefore, now this becomes g of 8. And I'm going to substitute 8 for the g function over here. And when I do that, I've got g of 8, get cute about it, equals 3 times 8 minus 1. And I've got y equals 24 minus 1 is 23. Okay, and that concludes our first section on video of 2.3.